Third one down. Explain the interaction between the meter stick and a charged insulator. So, we did it, but we really didn't draw it out. So we can start out, and here's our meter stick. And what I'm going to do, I'm going to take a view glass, just from chemistry, things that you can put on top to watch a reaction. And I'm going to balance that on there. A giant contact lens, yes.
Oh, giant. Yep, giant things.
So I charge this up, and you guys can see,
Metal on the end.
even if there weren't metal on the end.
So just think that we're both.
Okay, so the rod is what?
Negative.
Negative. The meter stick is neutral. Negative neutral interaction, we call that polarization. Now we can one-up it, so we'll get rid of the meter stick. Hey, hey, hey. Okay.
Charge that up.
You put it on top of the.
You want it on top of the can?
Yeah.
On top of the, yeah, there you go.
Good job, Dan.
I'm glad I have approval of Dane.
On top of Dane's
Why our meter stick doesn't balance right at 100 centimeters, I don't know. But it doesn't for some reason. So what I can do now, and this is actually more of an advanced topic of mechanics. It's a concept called torque. This one's going to be a lot easier to spin because I have a greater lever arm. Torque is force when it's applied some distance away from where it's going to rotate. The bigger your torque, the more rotation you're going to get. So here I just doubled the arm. The arm is distance out that I'm applying this force, which makes the 2 meter stick able to rotate better, or easier I should say, than the 1 meter stick. Okay? All good? So the idea here, here's my meter stick. And you can draw initially, so once again, this is the atomic idea. 2. And there is no preference in these atoms. Let's see, plus, to which way the pluses are, which way the minuses are. So this is the meter stick. But then, if I bring a negative rod close, this is net negative. What happens is the part of the meter stick that is close, well, I have those atoms. You have to think like an electron. Within the atoms, do they want the negative part of the atom to be close to this negative rod? No, so the negative side is going to run away. The negative side of that guy is going to run away. The negative side of that guy is going to run away. Up here, though, are they really close to that negative rod? No, so they'll be plain old hunky-dory. But right here, oh, pardon me, not net positive. It is local positive, meaning it is going to attract. And therefore, this thing spins. Because I'm only applying a force just right here. Same thing if I were just to pull right here on this meter stick. It's going to spin. If I'm just to push right here, it ends up spinning and almost shattering. Okay? All good? Yeah.
What's going on with the top of the meter stick?
Nothing.
Oh.
Same exact way as it was before. Positive and negatives, they're not close enough to that negative rod to really be affected. They look just like they did originally. And you might want to add the word on there somewhere, polarization, because the meter stick becomes polarized. It's still net neutral, but it has a local positive and a local negative.